Good, it's Bill. Let's have a look at this circuit here, okay? What have we got? What we've got is we've got our feedback connected to our inverting input. What do we know now about this OpAmp circuit? Knowing that we've got negative feedback, that means that these two voltages here, the voltage at the non-inverting terminal and the voltage at the inverting terminal will be equivalent. They'll be the same, okay? Well, as close to the same as possible, but we just call them the same in terms of doing our analysis. Now, what's different here is we've got this resistor here. What impact is this resistor going to have on our circuit? Is it going to have some impact at all? And if it is, what's it going to be? How's it going to change the way that this circuit operates? Let's just have a think about this, okay? So what I've got here is I've got the actual diagram I got when I got it, which is not what you're going to get, but I've got minus 1.31 volts here. So if I've got minus 1.31 volts here, and this is 0 volts, that means that there's going to be some charge, okay? There's going to be current, and this charge flow is going to go from the more positive to the negative, so there's going to be some current in this direction here, okay? Now, what it also means is that this minus 1.31 volts is everywhere on this node is the same voltage, okay? So that minus 1.31 volts will be the same here, minus 1.31 volts here. And what did I just say before about these, this negative feedback circuit, or the same with all of the OpAmp circuits that we're going to look at in this course, minus 1.31 volts, okay? So these two are equivalent, or so close to being equal that it doesn't really matter for our analysis purposes, okay? So knowing that, of course, we can just look at this circuit here and think, well, actually, this looks like a voltage divider, but I need to sort of get it clear in my mind that this is a voltage divider because, well, if there was any current here, then that wouldn't be an equal sort of voltage divider. So we need to actually apply a little bit of KCL to this node here and think about the current here, for instance, and the current here, and the current here. Well, actually, this is connected to an OpAmp input. So that means that there is 0 amps. There is no charge flowing into or out of these input terminals, okay? So that means that's 0 amps. That means that all the current that is there is the same as the current that is there, depending on which direction it's going to go in, of course. Let's just think about it. Of course, if we've got minus 1.31 volts here, what we've got is we've got this resistor R2, and we've got this resistor R3, and we've got V out there, and we've got minus 1.31 volts there, and we've got 0 volts there. We can see pretty quickly which way the charge is going, okay? And that way, you'll be able to think about when you enter the answer for the output voltage, okay, you'll be able to work that out using this voltage divider, or just simply with Ohm's law. You should be able to figure out from looking at the circuit now how to use Ohm's law or a voltage divider ratio on this. But you've got to think about which direction is the current, which direction is the charge flowing in this path. Now it's relative to this direction here, okay? So you have a think about whichever one you're given and your data that you've been given, which way the current is in terms of direction compared to this arrow. So that's what you've got to be careful of in this question. Think about that. Hopefully that'll help you get going with this. Cheers.